We're going to separate components of an ionic mixture by doing paper chromatography. We first mark a line about 1 centimeter from the bottom of the paper where we're going to spot our samples. We then mark a spot where we're going to add each sample to the paper. Our first sample will be silver ion. We use a capillary tube to place a small sample of the silver on the paper. Our second ion is cobalt. Our third is copper 2. Our fourth is iron 2. And finally, mercury 2. We make a spot of a mixture which will contain each of the standards. Then we put a spot of our unknown mixture. We know this unknown is not as concentrated, so we put 2 spots of it. We tape our paper into a cylinder, making sure that the edges of the cylinder do not touch each other, because then the solvent will not run straight up the paper. We put a small amount of our eluting solution into the developing chamber, being sure that the level of the solution is not higher than our original spots. We cover our chamber to saturate the atmosphere in the chamber with our solvent. This allows the solvent to run up the paper quicker. When the solvent has reached a couple centimeters from the top of the paper, we remove the paper from the chamber. We mark the solvent front, the distance that the solvent has traveled, with a pencil. After the solvent evaporates and the paper is dry, we need to visualize our samples. We can see the silver and the iron with no stain. They are also obvious in the known mixture. We spray the chromatogram with stain in order to visualize the other ions. We can see the silver, the cobalt, the copper, the iron, and the mercury each visually look different and have traveled a different distance on the chromatogram. We can see all of the ions in the known mixture and some in our unknown mixture. The copper is difficult to pick out because it is mixed with the others and is overlapped. Mercury is very difficult to see. We quantify the chromatogram by calculating RF values. The RF value is a ratio of the distance the sample has traveled to the distance the solvent has traveled.